Okay, I'm creating this video to help you answer questions related to variance explained. By now you know that R means correlation. If we were looking at a scatter plot and all the data points fell on a straight line, that would be a perfect correlation. As those data points move away from the straight line, the correlation becomes less strong. For a refresher, if you're interested, you can take a look at Christopher Magnetson's website and play with his interactive tool showing what correlations and variance explained look like on a scatter plot as you move those points around. To help explain correlation and variance explained, I want to take a look at some real data. This data is from years ago when Michael Jordan was still playing for the Chicago Bulls. To begin, I want to talk about a word that we use in research methods and statistics. The word is variance. Another word for variance is differences. Sometimes I think it would be easier if researchers and statisticians would just use the words that we use ordinarily. But when we're talking about variance, we're simply talking about differences. Let's use this NBA data as an example. We have the names of 25 NBA players some years ago. If you look at column B, you will see all of their salaries. You will see that there's a lot of differences in their salaries. The statistician isn't going to say differences, though. The statistician is going to say there's a lot of variance between their salaries, but it means the same thing. We humans are always trying to explain why things are different. If we have information like we have here, that is, correlations between variables, we can answer the question why things are different. For example, I might wonder why there are differences in what these players get paid. Once I calculate the correlations for the different variables, I can answer the question. Let's first look at the correlation between salary and points per game. As you see here, the correlation coefficient for salary and points per game is 0.81. That's a strong correlation. That means in general, the person who, on average, scores a lot during a game will earn a greater salary. And hopefully that makes sense. Teams are going to pay more money to those people who help them win games. Now, if I take that correlation of 0.81 and square it, I get 0.65 or 65%. The 65% is called the coefficient of determination or variance explained. In other words, this is explaining the differences in the players' salaries by looking at their points per game. So, I might look at this spreadsheet and say, my goodness, there's a lot of differences in what these players get paid. I wonder what accounts for that. By taking the correlation of 0.81 and squaring it, we would be able to answer that question by saying, I can't explain 100% of the differences in their salaries, but 65% of the differences in the players' salaries can be explained by how many points they score in a game. And that's valuable information. Anytime you see a question on a test that says how much of the variance can be accounted for or how much of the variance is associated with, that question is asking about variance explained or R squared, and that's important to remember. Now, take a look at this correlation matrix. It shows the correlation coefficients for all 5 variables. We have salary, we have points per game, minutes per game, rebounds per game, and assists per game. Doesn't it make sense that there would be a relationship between the amount of time a player spends on the court in a game and the number of points that they score? To me it does. A player can't score unless they're on the court playing. So just intuitively, there seems that there's going to be a relationship between these two variables. Now, if you look at this correlation matrix, you see that the correlation between points per game and minutes per game is 0.78. So, with that information, I would like you to tell me what explains the differences in the number of points a player scores in a game. Well, there could be a lot of variables that affect how many points a player scores in a game. However, if we look at just one variable, minutes per game, we can answer that question as it relates to minutes per game. The way I would do that is I would identify the correlation coefficient between points per game and minutes per game. In this case, it is 0.78. That is our Pearson R. Now, to get the variance explained, I have to take that R and square it. And when I do, I get 0.61 or 61%. Now I can answer the question, why all the differences in the amount of points players score in a game? And I would do it this way. I can't explain all the differences in why players score differently in a game, but if I look at minutes per game, I can tell you that 61% of the differences in the players' points per game can be explained by the amount of minutes they play in their game. And once again, that could be depending on the context, that could be very useful information. So, this is your introduction to variance explained. It's a powerful statistic that's not too difficult to calculate.